Hey guys, welcome back to the Rust beginner tutorial, and we are going to be picking up right where we left off on the blockchain info app. So we just saw our first request successfully made to the API. We got information about the chain, we converted it to a struct, and we did some stuff with it. So let's follow that same process and let's implement the rest of our application. So step 2 is going to be get information about a wallet. So let's go ahead and build that. First, we're going to go back to our requests here, and we're just going to create a new method. I'm just going to copy this one because it's going to be very similar. And we're going to say, instead of blockchain status request, it's going to be address request. And we actually want to pass in an address, and we'll make that a string slice. And our return type, instead of blockchain status, you guessed it, blockchain address. Now, the endpoint is going to be a little bit different. We're still going to use our root here, but once we get up to this API slash, we got to go see in Postman what we're using here. So get address, it's API slash v2 slash address slash your entered address. So what we want to do is actually concatenate this string slice with that other piece that we just talked about and the address that we entered. So they're all string slices, and this is how you do that. So we're going to reference, but we're going to reference this whole bit in an array structure. And so you got the host root. We're going to add v2 slash address slash, and we're also going to make a reference to our address. Now at the end of that array structure, you just type dot join, and this is what's called a delimiter or a joiner, and this is basically what you would join each of these strings with. So like if I put something like an equal sign, it would stick an equal sign in between the host root and this, and then in between this and the address. But we want nothing there. So it'll create for us the full URL. So everything else is exactly the same. We can even keep this whole bottom line exactly the same. And now let's go back into main RS, and let's go ahead and actually do some output here that's going to show us what we're getting from that wallet lookup as well. So here we're going to type, let's do let blockchain address, which is going to be of type blockchain address, equal blockchain info, blockchain address request. And now here we need to type in an address. So I'm going to put this address variable in there for now, but we haven't defined that yet. So again, we want to make use of that .m feature so that we can hide this address. Now, an address is not necessarily sensitive. There's nothing anyone could do with it. But just as like an example of like best practice, I guess, we're going to demonstrate that again with .env. So first what I'm going to do is I'm going to cut this out of main, and I'm going to create a new function, and I'm just going to call it blockchain info app. Same name as our application. And we're going to get the address as a string slice as part of this function, and then I'll stick this stuff back in there. So now address is being passed in here, and we're going to run it right here, and we'll just quickly do a print statement, and we're just going to say like analyzing transactions for Bitcoin address. And like I said, address is not super sensitive, so I'm going to print it out, but if you guys don't want to, you definitely don't have to. And again, we're using our struct, right? Like just like we did up here where we're getting the attributes coin and chain from our blockchain status struct, we're again going to get the wallet address from our blockchain address struct. So you've seen this before. Now, we need to pass this value in, and we need to do it with .env. So in main, let's just do let entered address equal .env var, and our key is just going to be all caps wallet. And again, expect error reading envar or something like that. And then with that entered address, we're going to fire off the blockchain info app method and fire in the entered address. Cool. Now, as we saw before, you're going to want to go to your .env file. And in it, we're just going to go ahead and create that same thing like we did with the API key, wallet equals, and then just put your wallet address here in quotes again. Nice. Now, I've gone ahead and added my wallet off screen, but regardless, I guess it doesn't really matter since we're printing it out, but this is going to do exactly what we talked about. So let's give it a run. And now that we're kicking this off, you're going to see the outputs that we saw earlier. We're querying Bitcoin chain main, analyzing transactions for Bitcoin address, and there's the address I stuck in there ever so secretly. Nice. Okay. So we are successfully reading the attributes of our status struct and our wallet struct. And now let's implement the rest of the logic. So first of all, let's dock up some of this functionality here in this main function here. So first of all, if you notice that all that stuff was printed out at the same time, what we can actually do is we can tell Rust to sleep for a minute. Well, technically we're going to do a few seconds, but still, that's pretty simple to do. So we're going to add a couple of imports up here. We're going to say use .env, and we're going to use a couple different traits of std. So you've seen std.io, but rather than doing these all on different lines, what we're going to do is actually add this curly bracket. And we're going to use io, we're going to use thread, and we're going to use time. And that's how you do all of those in one line. Now, additionally, you can see we're starting to accumulate quite a bit of use keywords. So what you can actually do, a little bit cleaner implementation, is you can just do use with a curly bracket, and then you can declare each of these inside the curly bracket and add a closing bracket with its own closing semicolon. And then just convert all the other semicolons into commas. And that is a valid use statement as well. And Rust will know as a glob to import all of these. So pretty neat, just a nice cool little concise way to do it. But anyway, so now what we're going to do is we're going to tell our application to sleep for, let's say, 2.5 seconds, just to let the user output be a little bit more friendly. So let sleep time equal time, there's that time module, duration from millis, and we'll do 2500 millis, which is going to be 2.5 seconds. Seems fair. So then the actual command to sleep the program is thread sleep, and we're going to plug in the sleep time we created. And now that will sleep for 2.5 seconds. And once it's done sleeping, we're going to print out, let's say, you have a total of blank transactions. Now, how do we get the total transactions? We know from the return value, from our blockchain address struct, we have a vector of transactions. So how do we count how many are in the vector? Well, there's a built-in method to do that. You can actually just do a reference to the blockchain address struct. And since that attribute is going to be txids, we're going to reference txids dot length. And the length is going to tell us how many transactions are in the vector. Nice. So now that that's done, we're going to give this a run. And here's our original output. Wait 2.5 seconds. You have 3 transactions. And for that wallet I used, you can see that there they are right there. There's the length and there's each of the hashes. Okay, sweet. So now we said we were going to do something with those hashes, right? We were going to look them up. So yeah, it's cool to print out the length right there, but let's also use each of the transaction IDs in the vector to do stuff with. So you saw I imported std.io, which if you remember we used in a previous video to take user input. I thought I would just rope that into this. So what we're going to do is we'll do a print line, and we're just going to say, do you want to query these transactions? Just give people the option. If they don't feel like looking them up, then they don't have to. And when we ask that question, we're going to obviously expect some user input as a Y or an N to tell us to proceed. So just like we've done in previous videos, let the mutable variable equal to command equal a new string. And then of course we're going to do IO stdin dot read line. And we're going to reference the mutability of command and override it. And if we get a yes, if command.trim.eq equals y, then we're going to proceed with the application. Now, this is the part where we're going to start looking up those transactions and pulling some information from them. So just to start, we're going to say, we will look up the following transactions. And just like we mentioned, we're going to start actually using the different hashes in this transaction IDs vector. So first we're going to quickly do like a thread sleep. And I'll just do the same, like sleep time again. And once that's done, we're going to print our transaction hashes. So in order to print a vector, you can actually use this syntax here. We can use the colon, the hash, and the question mark. And that's going to do a couple, question mark. That's going to do a couple things. We talked about how this with the question mark handles options. When you add the hash, it also beautifies a vector. So you've got two things going on there. If the vector happens to be empty, it'll print none. And if it isn't empty, you got that beautifying aspect, which is just going to make it look cool and not look like a clunky typical vector. Not super important. But anyway, we'll reference our blockchain address struct again. And this time we're just going to take the whole vector, TXIDs, and we'll print it out. Nice. So you guys know what that's going to look like. I'm not going to run it right now. Let's go ahead and do the final REST call, API call, that's going to give us the transaction information. So again, we can copy this address one that we wrote. And this time, instead of blockchain address request, blockchain transaction request. And we're going to input a transaction hash, again, as a string slice. And our return type is going to be a blockchain transaction struct. Nice. Now, let's just take a look at our URL again. So if we go into transaction, we can see, again, we have the v2, but instead of address, we have tx. So we'll change address to tx. And then obviously our variable is now called transaction. So that's going to give us the proper URL to look up a transaction by hash. And same return type of syntax here, we're going to get the transaction struct. Cool. Now back on our main function, once we've printed that out, we'll do another sleep. We probably don't even need this sleep up here. We'll do a sleep, and then we're going to say let mute balance of an I32 equals 0. Now, here's where things are going to get a little bit tricky. But I promise if you guys follow along, you're going to understand what's going on. If any of you guys have programmed before, this is going to look very familiar. But what we're going to do is initialize this mutable variable as the balance. And then every time we look up a transaction, we're going to get some information about it. And we're going to add to this balance. And we're going to try to guess what that Bitcoin address balance is right now, based on all the information on the chain. So for starters, what we're going to do is iterate over each transaction ID and we're going to make a reference again to the blockchain address.txids variable, that vector. So iterating over that, we're going to do a couple of things to calculate basically the Satoshis in and the Satoshis out. So I don't really know why it's represented like this, but from my research, I noticed that V out is actually Satoshi's in and V in is Satoshi's out. So I'm not really going to try to ponder why that is, but if you notice that it's kind of backwards, that's why. So now we're going to continue on, and we're going to go through each of these transactions. And basically what we want to do is for each, we want to take the V in and the V out, and we want to get the value for each of those and just do a simple like summation. You know, like we want to get like in minus out and come up with the sub balance for each transaction, and then add the sub balance to our total balance. So to do that, we'll let the subtotal of V in, again, another I32 equals 0. And we're also going to let the subtotal V out equals 0. And now every time we get a new transaction, we'll set the subtotals back to 0, which is good. These are subtotals, that's what we want. And let's say we add some logic here. At the end of the logic, we're going to add to the balance, plus equals is going to take the value of balance and add something to it. We're going to add the subtotal V out minus the subtotal V in. Cool. Now, what we're going to do is actually add the logic to look up each transaction. So right here where we put this comment, this is where we're going to fire off that request that we wrote here. For each transaction in the vector, we're going to look it up on the chain. So that's going to look like this. We've seen this already above. We're going to do let blockchain transaction, and that's going to be of type blockchain transaction, equal blockchain info, blockchain transaction request, and we're going to reference that TXID from our iteration. So that's going to give us the struct of the blockchain transaction. And like we've been doing, we're going to just use the fields of this struct to do our calculations. So we know that this transaction, when you look it up by hash, like there's going to be a lot of people's transactions in here, right? Like only a couple of them, based on whatever you did, are going to match your wallet address. Like some of them aren't going to be your wallet. So we need to actually match the wallet that was entered into the app to any wallets on that transaction block that match it. So let's do let match address equals string from address. Now this is the last time that we're going to need the address variable. It was entered up here at the top. It was used to look up the address and get the information back. But now this is the last time we're going to need it. So we're going to actually destroy it. But since we're in a loop, it's not going to be destroyed until the loop finishes. But nonetheless, we're cool with it. So now that we've got our response blockchain transaction and we've got an address to match the hashes to, we're going to do both the V in and the V out one at a time. And we're going to simply do Satoshi's in minus Satoshi's out and add that to the sub balance. Then we'll print the sub balance out and add it to the total balance. So that's going to look like this. For TX in, and we'll reference the blockchain transaction. And that's going to be the struct again. And we're going to reference V in. So for each transaction in V in, if the transaction dot addresses dot contains match address, then we're going to add subtotal VIN. We're going to add to it the transaction dot value, and we're just going to parse this from a string into an I32. And that's just in case like we for some reason get back a string, because in here in the JSON, value is actually represented by a string. I'm not really sure why, but we're going to put it into an I32 and just do unwrap. So there's kind of a lot going on here. I'm sure you could figure out the gist of it, but basically TX is represented by each item in the VIN vector. So if we look at our vector here, we've got a vector of VN. So each TX is going to be a VN struct. And we want to get the value and we want to match the addresses. So addresses is actually a list. So that itself is also going to be a vector. And so we just want to look if this vector contains the string of our address. If it does, we're going to add the value. In this particular use case, it seemed to me like addresses are always going to have one item in them. But if they don't, like, your logic may change a little bit, but for simplicity's sake, let's just pretend that they all have one address in the vector. Anyway, going back to what we did, so this is going to append to the subtotal any values that are detected that match our address. Makes sense. And we're just going to copy this loop because we'll do the exact same thing for vout, and we'll make sure that we add it to the subtotal vout. Nice. So there you have it. Now, after we append to the balance, the difference between the two, the sub-balance, what we want to actually do is a little bit of a printout that's going to talk about the details of that transaction we're looking up. So I won't make you guys painstakingly watch me type this, copy it from my GitHub, but this is kind of what our output's going to look like for each transaction. And then, as you can see, here is the transaction ID from our blockchain transaction entity. And then here's our subtotals that we've been calculating throughout, and then the balance at this current transaction. So for each iteration of this loop, we're going to see this printout that's going to detail the current transaction. And then at the end, when we're done with this loop, close it with a semi, we're going to actually add this print statement here. And this is going to print out the current balance. This one will be in Satoshis. And then as you can see right here, we've added the conversion for the balance in Bitcoin. Nice. So, as we saw, we're going to go through each transaction in the vector, look it up, and we're going to calculate the subtotals for each V in and V out. And we're going to print this stuff out and eventually get the current balance. And that's it. That's a wrap. Let's see if this thing works. Looks like it's going to work. There you go. Querying Bitcoin chain main. You have a total of 3 transactions. Do you want to query these transactions? Yes, we do. There's the transactions we're going to look up. We got our time sleep. And then there you go. Printing out information about each transaction and then the balance. And just as a side note, that actually is the balance in my particular wallet. That wallet is just like a side wallet I have for this example. Don't pity me because I'm poor. But as you can see, this works. And like I mentioned before in the previous video, if your address is it's using the same address every single transaction, you could do this with your own wallet. And it'll give you your current balance in BTC. So congratulations, you guys just built a more robust sample app. This one is actually doing crypto stuff. So, this is the end of the playlist for Rust beginner tutorial. And if you made it this far, hats off to you. And I hope you guys enjoyed everything that you saw, and stay tuned for more videos and more playlists.